let's explore the emerging attack surface challenge that I think is going to fundamentally reshape security architecture as we know it. These aren't really distant threats, but I do believe that they are evolving realities. First up, we have AI and ML systems, and here I think it creates an entirely new attack dimension, one that most aren't even aware of. If we think about model supply chains, that now becomes just as critical as software supply chains. And if we take it one step further, every AI endpoint now becomes a potential attack surface. So you can already start to see here that the attack surface is exponentially growing. Every model interaction, so every model interaction with large language models, that creates a potential poisoning opportunity. And if you take this into consideration, just think about AI systems that they don't just process data, they learn from the data. And each learning cycle, being trained, that in itself introduces new vulnerabilities. The solution is implementing, more AI model validation frameworks, creating model behavior baselines, developing runtime anomaly detections, for instance, that specifically are built for AI operations. Next up, we have quantum computing. And here it's starting to transform our core security assumptions of what we already know. But what's fascinating is the transition period is creating more of a risk than quantum future itself. We have systems using hybrid encryption or mixed quantum and classical protocols, for example. These transition points are going to become prime targets for attackers. Smart organizations are already building quantum migration frameworks as we speak, and identifying the quantum vulnerable systems. They're going to create crypto agility programs, and I know that this is probably talking over somebody's head because this is very forward thinking, but developing protocol transition strategies that prevent security gaps during the migration phase. Again, you're going to see more of this as we start to talk more and more about quantum computing. Obviously, there is more discussion about quantum computing and how it is now a reality and not just theory. So the attack surface is going to be dramatically impacted by quantum computing alone. So if anything you do, keep an eye on this. 5G networks, they don't just expand the attack surface, they're really fundamentally changing the nature as we know it, because you're looking at network slicing that creates dynamic trust boundaries. And each one of those slices becomes its own security domain. But these domains overlap, they interact with each other, and they're reconfigured in real time. So it makes it a huge challenge in order to get a complete grasp on things. Now, the challenge isn't just providing better 5G security. It's really about more dynamic security orchestration. Again, we're talking about automated security policy adaptation. We're talking about building real-time trust boundaries and making sure that those real-time trust boundaries are recalculated in real time. The security controls that move and adapt with network slices, that's all done in real time. Then we have edge computing, completely inverting our security model. Here we are talking about protecting a core. We're talking about securing a mesh, and every edge node becomes processed. Every edge node is processing sensitive data, and it's making critical decisions. And all of that is creating attack opportunities. So I think for future edge security, it's going to require autonomous defense mechanisms, local decision making. So pushing the decisions for security at the edge instead of thinking about it just being enforced at the core. Distributed trust models, for example. Think about security controls that are able to adapt based on local conditions, what's happening local, and not just central policies, because you're in a distributed model here. Now, this one is interesting. Last but not least, we're talking about metaverse security. And it isn't just about the virtual assets in metaverse, but it's more about like a blended reality protection that's needed. You're going to have physical security that merges with digital security. Again, when I say identity is going to be crucial or become very pillar going forward, it's so true in the metaverse, because we talk about identity management now spanning both the real world and virtual worlds. So we're going to need to see new security models being built and zero trust frameworks that are able to understand virtual contexts, not just physical contexts. The identity systems that manage multiple digital personas, for instance, have to be able to provide better access controls that work across both boundaries, across virtual boundaries and the physical boundaries. Now, here's where I think these challenges are unique. All of these things will interact with each other. You're going to have AI systems running on edge nodes in 5G networks that support metaverse operations that happen to be protected by quantum encryption. Each layer will add its own unique complexity, and this will create new attack vectors. So you can see that all this is really kind of tied together, or will be tied together, so you can see how much more complex security will become. The future of attack surface management won't be just about providing better tools, better security solutions. It's going to be about fundamentally building new security models, like I said earlier, and having dynamic trust calculations, taking adaptive security architectures to the next level, and being able to control, to put controls in that evolve just as quick as the threats do. And that is going to be a challenge to build, but that is what is needed going forward in the future.